Hello guys, so because my last lesson was so long, I really want to make this lesson short. So here is a lesson about electronegativity. There's a bookwork associated with this lesson. We will do this in class. It's all these questions on pages 90 to 93. And there is also a quiz associated with this lesson, so you should be prepared for that. That should be coming up the day that we talk about this lesson in class. The aim is, what is electronegativity? Please do copy down this do now right here, and it should go on a separate piece of paper in your binder that'll be filed under the classwork section of your binder. You can also add this homework title to the top so that you know to do that, and then copy this down. Today's mini lesson is about electronegativity. It's quite a mouthful. I'll say that for you again. Today's lesson is about electronegativity. Electronegativity. Electronegativity it's not even measured in a real unit, It doesn't even have a unit. Electronegativity is really just a measurement of how much an atom wants to gain an electron. And it's sort of like, it's almost like a GPA, especially because it's on a scale of 1 to 4. And it's just comparing one atom to another, how much one atom wants to gain an electron versus how much another atom wants to gain an electron. And again, no unit. It's not a physical quantity. It's really just a measurement. So just a measurement. It's not even like a real measurable physical quantity. It's just one element versus another. So just to make sure that we understand this terminology, I have a couple of questions. The first one is, do atoms with high electronegativities want to gain or lose electrons? Why? Pause and think about the answer, and then we'll come back. So there's definitely no magic in this answer. The definition of electronegativity is a measurement of how much an atom wants to gain an electron. So elements that have high electronegativities want to gain electrons. Similarly, atoms with low electronegativities do not want to gain electrons. And generally, that also means they want to lose. Now, it's not always true, but it's generally true. So I tried to reflect that in my answer here by saying, for sure, that atoms with low electronegativities do not want to gain electrons, and also usually that they would want to lose electrons. I will be able to show you an example of what I mean for that in a few seconds. So what class of elements is likely to have high electronegativities? Those would be the elements that already have, let's say, 6, 7 electrons in their valence shell. If they already have that many electrons in their valence shell, if they're so close to getting 8, then of course they're going to have higher electronegativities. And additionally, it's not only just because they have extra electrons and they're really close to having 8. The other thing that's really important is that those atoms, the ones that have 7, 6 electrons in their valence shell, usually have very small atomic radii because they're on the right-hand side of the periodic table. So yeah, being on the right-hand side of the table makes your atom really small. If the atom's really small, electronegativity tends to be higher. And additionally, those atoms also have 6 or 7 electrons in their valence shell and would have a stronger desire to gain electrons. And it just occurred to me I never said what class of elements I was talking about. That would be nonmetals. And again, the two things that I think are the most important here is that they have a small radius, so it's easier for the nucleus to reach out and grab some extra electrons. But they also have 5 to 7 electrons each, so just want to gain a couple more, and that means that they'll have high electronegativity. Similarly, the class of elements that's likely to have low electronegativities are elements with basically the opposite properties. So elements that have large radii and just a few electrons the large radius means that it's harder for the nucleus to reach out and grab an electron, and just having just a few electrons means that they're more likely to lose electrons than they are to gain them. So I'm talking about metals. I think I forgot to say it again. So again, having that large radius means it's hard for a nucleus to reach out and grab an electron. And having just 1 or 2 electrons in your valence shell means it's much easier for you to lose those 1 or 2 than it is for you to gain 6 or 7. All right, let's fill in this data table, and then that will help me explain a lot of this to you. So fluorine's electron configuration is 2,7. Nitrogen's is 2,5. Argon is 2,8. 8. And lithium is 2,1. So in terms of electronegativity, we can just judge it really based on the number of electrons in the last orbital. So let's do it that way. Since fluorine has 7 electrons in its last orbital, it is going to have a very strong desire to gain 1 more, so I'm going to go with high electronegativity. Nitrogen has 5 electrons in its last orbital, and it is going to have some desire to gain 3 more to fill its valence shell, so I'm going to say high, perhaps medium high, but definitely higher. Argon, this is an interesting case. It has actually more than 5 to 7 electrons. It has 8 electrons in its valence shell, which means that its outermost shell, its valence shell, is full, which is stable for all atoms. And this is a reason why I would say that the electronegativity for argon it's 0, it's none. I'm just going to write in none. The electronegativity is very, very low for argon because it already has a stable electron configuration. But I do want to point out something I alluded to earlier, where I said, it's up here in number 2, I said, do atoms with low electronegativities want to gain or lose electrons? And this atom has a really low electronegativity at 0, but it definitely doesn't want to gain electrons, but it also doesn't want to lose electrons. It wants to stay exactly where it is. So that's why I said that atoms with low electronegativities usually want to lose electrons, if I'm talking about a metal. But if I'm talking about a noble gas like argon, then absolutely not. All right, so let's talk about a metal again. For lithium 2,1, it only has 1 electron in its valence shell, so that means that it's going to be much easier to lose an electron than it is to gain. In other words, it has a very low desire to gain more electrons, so I'm going to go with very low on that. In terms of ionization energy, this is from yesterday. Ionization energy is based on the amount of energy that you would have to spend to remove an electron. So if I were going to try to remove an electron from, let's say, this fluorine atom, it's going to resist that a huge amount because it actually wants to gain electrons. So since it's going to resist the loss of an electron, it's going to have an extremely high ionization energy. Nitrogen, similarly, will have a high ionization energy because elements that want to gain electrons definitely don't want to lose them. Argon also will have an extremely high ionization energy. It doesn't want to gain electrons. It doesn't want to lose electrons either. So it definitely has a low electronegativity and a high ionization energy. So this is sort of the interesting one, the noble gas. And lastly, lithium. It does not want to gain electrons. In fact, it does want to lose electrons. So it has a low ionization energy. So basically, to take away here, low ionization energy means that you want to lose electrons. High ionization energy means you don't want to lose electrons. And similarly, high electronegativity means that you want to gain electrons, whereas low electronegativity means you do not want to gain electrons. So over here, I just went ahead and put in some very quick explanations for each of these about whether they want to gain or lose, or gain and not lose. And I'm talking about electrons here. So fluorine wants to gain electrons, not lose them. That explains this and this. Similar for nitrogen. And then for argon, it does not want to gain and does not want to lose, so that explains that and that. And for lithium, it does not want to gain, but it does want to lose, so that explains both of those things. And my last question on this page says, why do you think, or what do you think might happen if an atom with a high electronegativity, so that means that it does want to gain electrons, and an atom with low electronegativity, meaning that it doesn't want to gain electrons, and potentially that it wants to lose electrons, then what do you think would happen if they ever met? So think about your answer, and then I'll have one when you come back. So to paraphrase, the high electronegativity atom would take electrons from the low electronegativity atom. So there is a story I wrote that we're going to read in class tomorrow. So this is one page of it. There's another page of it. But I need you to copy down this pair up right here. And that will go right underneath the do now, and we will work on that in classwork tomorrow after we read the little story. And also, you have some summary questions. So please copy these down as well. So you have, so far you have a do now, a pair up, and a summary, all of which are quite lengthy, so most of your notes today are those, and I apologize. But that concludes the lesson, and get ready for some story time tomorrow, in addition to some question answering. Bye-bye.